PERT CPM, PERT Program Evaluation and Review Technique. CPM Critical Path Method. PERT CPM are network based methods designed to assist in planning, scheduling, and control of projects. If you take any one project, and we should know when it will be completed, and the customer will ask you what is the duration you want to complete this entire project. So at that time we need to give approximate deadline to complete the project. Any project, it consisting of several activities, and these activities will be depending on one another. So we need to keep all the activities together and make a network model. So here in this part CPM, we are going to analyze this network model, and we are going to find out the duration for the project. Here majorly there are 4 steps involved. The first one thing is the project activities, which we can see in this slide. So project activities, we are going to take all the activities and its dependency, and then based on the dependency on the activities, we are going to make the network diagrams, and from the network diagram we will be calculating the network calculations. Then we will be making the time scheduling. If there is a problem with the time scheduling, then we will be going back to the network model, and we will modify the network model, and then we will come to the network calculation, and then we will go to the time schedule. So for example, simple example, you have given a project to a company, that is a construction of a bridge. So this bridge consisting of purchasing the raw material, or the purchasing the procuring the material for doing that bridge, and again steel work and concrete work, and then finally the testing. So these all things, activities will depends one another. So and there are some works which can parallelly go, and procurement, as you are keep on procuring material required for construction of the bridge, so you will be parallelly doing some other work. So initially you will be purchasing the steel, and at that time they will start working on the steel, and again you need concrete, cement, and sand, etc. These all things can be parallelly procured, and parallelly they can work on the construction of the beach. So this way we are going to see how many activities are there in order to complete the entire project, and what is the dependency on each activity. So for example, if they wanted to make the pillars of the bridge, so they need to first have the procurement of the material steel, and when they wanted to make the pillars, they also need some the material which can able to hold the concrete in the pillar. So like that, there are some activities which are depending on each other. Finally we can able to tell this project will take this much duration. And here we are going to learn one by one sequentially. So so for example, we will take one activity. The activity name is, let us say, A, and this A activity is taking around the 3 days to complete this activity. And here one is the starting of the activity. This is called as the starting of the activity, and it will take 3 days to complete. And this is the 2 is the ending of the activity. And this is one activity, if you understand. And if suppose there are several activities in the project, let us consider another activity. So here the activity name is B, and the activity duration is 5, and this activity will start with the 2. That means ending of activity 1 will continue by the activity B, that will be for 5 days, and the ending of the activity B will be 3. So these 1, 2, 3 are called as the nodes, and A, B are called as the activity. So every activity will have its starting time and ending time. So the starting time of activity A will be 0, and the ending time of activity A will be the 3 days, and after 3 days activity B will start and it will continue for 5 days. So the total the activity B will be completing in 5 days. The total duration to complete this project will have only two activities. Let us say the total time it will take to complete is 8 days. So that is how we are going to evaluate how much time this project will take in order to complete the entire project and all the activities. So we are going to see the critical path, that also we will see in the through the example. So let us take one example and try to understand how we are going to identify the critical path. Problem 1. A construction project consisting of activities A to F with the following time duration in months. Identify the critical path and the total project duration. So this project consisting of 6 activities. These activities are given here: A, B, C, D, E, F. This is like a construction project. So they are need to first clear the site. That is it will take for the 3 months. Everything is in months. And then B activity is excavation and it will take 5 months. And C is the material procurement and this will take 4 months. And D is the foundation pouring, it will take 6 months. E is the structural steel setup, it will take 6 months. Finally roof installation, that will take the 4 months. So now we need to identify the critical path and we need to also see what is the total project duration to complete this project. So let us see this network model. So this is the network model which they have already given, and this will be showing the relationship with one activity with the another activity. Now activity B and activity A, what is the relation it is showing, and activity A and D, what is the relation it is showing. That means unless the first activity is completed, the B activity and D activity cannot be started. So here if you see, A is site clearing. That means unless the site is clear, they can't do the excavation and they can't even do the foundation pouring. So the first the site clearing need to be done. So that is how it will be going. Now what is meant by critical path? The critical path is the maximum time, the path which will take the maximum time in the network. So if you see the maximum time in the path, we are going to see that is the critical path. Let us consider in the next slide. Now the critical path we need to first identify. The critical path is the path which will take maximum time in the network. So now this is the starting of the network, or the first the starting point of the entire model or the project, and the 6 is the ending point of the project. So during this starting to ending, these are the network model. In this network model, whichever the path is taking the maximum time, that is nothing but the critical path. Now let us first see the first path. So here these are the activities and this is the path. I am just calculating the duration. So let us say I am taking the path A, B, C and F. In this path, the time duration it is taking in this path, let me calculate. So if I calculate, A it is taking 3 months, B it is taking 5 months, C it is taking 4 months and F is taking 4 months. Total if I calculate, it is taking a 16-month duration in this path. And let us go to the next path, that is A, D, E and F. In this, the time duration taking with each activity will be 3, 6, 6, 4. If I calculate, if I add all these activities, and it will be coming a 19 months. That means the critical path is the path which will take a maximum time. So out of these two the paths, so the second path is taking maximum time, so that is called as the critical path. So this is taking a maximum time, So this path is called as the critical path. So this is the critical path. And what is the project duration? The project duration is 19 months. 19 months if you travel in the critical path. So the critical path is the path which will be taking the maximum time, and the maximum time we need to tell to the customer to complete the project. So why we are not considering the minimum time? Because within 16 months these activities will be completing. These activities will be completing, but they can't complete F, because in order to start the F they need to even complete E also. So to complete the E, so it will be taking 3 plus 6 plus 6. So there are 15 months it will take. Then only F can be started. So even though this B and C is completing the work very fast, and D and E is taking more time, that is why we need to consider the maximum time. The maximum time will be available in the critical path. So that is how we need to solve the problems. So let us try to see one more problem. So determine the critical path for the project network in a below figure. All the durations are in a days. Now here there are some activities given. The activity A, B, C, D and E, F, G and H. And here there is one more activity from 4 to 5, but it is given in a dotted line and arrow mark. So this is called as a dummy activity. That means it don't take any time for doing this activity, but only thing is it will be showing that there is a possibility that once after you complete this fourth activity, only then the fifth activity will be starting. So that means this dummy activity is showing the relation or the direction of the direction of the work. Okay, so that means after fifth activity need to be started only after completing third activity, E activity and this dummy activity also, even though it don't take any time. So fourth activity need to be completed before it start the fifth activity. So that is what this dummy activity will tell us about. So now let us see what is the critical path. We need to first identify the critical path, and then we can easily identify the time duration to complete the project. So now let me take, there are several the paths which will be coming from the starting point to the ending point of the project. Let us see one by one. So now if I take the first the path it is starting from B and then directly F. So that means node 1, 3 and 6. So it is taking 6. The activity B is taking 6 days. Activity F is taking 11 days. So the total 17 days. And another the path is B, E and H. So B is taking 6 hours, 6 plus 2, 8, 8 plus 12, so 20. So then this is the second path, and third path, let us come to the A. So it is starting from first activity A, C and then E and H. So in this path we will be getting the 5, 3, 2, 12, so 22 days. And then let us go to another activity, another path, that is A, D, and then we can go to with the dummy activity and then H. So in this way we will be getting the 25 days. Then another path, that is A, D and G. So in this path we will be getting 14 days. So out of these all activities, all the path, the path A, D, H is taking more time. So this is called as a critical path. So here the critical path is A, D and then H is the critical path. The duration in this critical path is 25. So that is how we can easily calculate the critical path and identify the critical path and the project duration. Let us solve one more problem. So determine the critical path for the project network in the below figure. All the durations are in days. So now if you see here, there are so many activities are there, and the starting point of the activity is the 1, and ending point of the activity is 7. So here the activity is starting, there are several paths. So let us solve this the network let us try to identify the critical path in this diagram. So now let me take this critical path. So before that, I just wanted to tell one more method through which we can easily identify the critical path. So every time if you wanted to see how many paths are there, it will be taking lot of time. So instead we can see one method, another method. So the calculating the weightage at the node point. So calculating the weightage at the node point. With that we can able to easily solve the critical path. And let us say, so here this is the starting point. So in this starting point, the time duration for starting point is at this node is 0. So I will be writing at each and every node what is the the starting point of the activity and what is the maximum time which will be completing the activity. So if I write these two, so then it will be very easy to identify the critical path, because the critical path will take a lot of the maximum time. So here let me take this activity A. So it is starting at a 0 point. It is starting at 0 point, and it is starting at the first node, and it will be completing at a third node. So the duration it is taking is 3 days. 3 days. So here the starting at first node, the time duration will be 0. So now I will be writing here that this is 0. So here the square, it shows that I am moving, calculating the durations in the forward direction. So let me take a square, and inside I will be writing 0. So that means this is the starting of the activity, and it will be taking here after 3 days it will be completing, the activity A will be completing after 3 days. So here I will be writing 3. Now if I come this side, so the activity D, so it is started at 0 time and it will be ending at the 2 days. So here I will write the node 2, the weightage in the days or the duration will be 2. So that means this is the maximum time it will be completing the activity D. And so E, let me come to the E. So if I come to E, it will be taking, so 2 plus 2, 4. But to this node there is one more, the activity also need to complete in order to reach the fourth node. So that is called as F, activity F. So here if I take 2 plus 2, 4, 4 is the duration, the time taken to come to this node, time taken to come to this node. But doesn't mean that the only one path is available here, and there is one more path to come to this node. So that is activity A and activity F. If it completes, it will be coming to the node 4. But here the time taken to come to this node in this path will be 4, but the time taken to come in this path will be 3 plus 3, that is 6. So whichever the path is having the maximum time, that maximum time we will be considering in order to write the duration at the node. So here the duration at the node 4 will be 6 instead of 4. So here in this path it is coming 4, but because we need to calculate the critical path which will be taking the maximum duration, so we need to write the maximum, the duration here. So that means it is 6. Okay, then if you come to this path, so then here already only 3, this is the starting point of the activity, the 3 days, and then the plus 2 days, so it will be 7 days. And the 3 plus 2, 5 days. But here there is one more arrow, that is the dummy arrow, dummy the activity. But this is showing that from here, from the dummy activity, if you go here, this 6 will be coming there, because the dummy activity will take a 0 time. So the 0 time, that means here 6 the duration, and the same 6 duration will be going here. So here in this path, if you are coming, it is taking 5, and if you come to this path, it will be taking 6 days duration. So whichever is maximum, that we will keep here, and 6 is the maximum, so we will be keeping the 6 here. Then let us go to another node here. So the node here will be coming from 4th node to 6th node, that will be 3 plus 6, 9. And if you come to this path, 6 plus 7, so that will be 13. So which path will give more maximum time? So this path is giving a maximum time, so that will be taking as 13. Okay, that is taking as 13. So the maximum time will be taken. And then next one will be sorry. So next one will be, let us see the final activity which is taking the how much, which is so if you see the final node, then 5th node to 7th node, if you go 6 plus 5, it is 11. So this path is giving a 11, and if you take this path, so 13 plus 6, it is giving 19, and if you come to this path, 6 plus 2 is 9. So compare with these three paths, this path is giving a maximum time, so that we will be considering as the final the duration, which is 19. So that means the total duration it will take to complete the project is 19 days. And the critical path will be starting from here. So whichever the path it is taken the maximum time, that path we need to come across. So that is this, in this way. So that we need to make the highlight. So that means 1 to 3, and 3 to 4, and 4 to 5, and 5 to 6, 6 to 7. So this is the critical path which come across this this path. So with this way we can easily calculate the maximum duration it will take to complete the project, and also we can able to see what is the critical path with the easy method. So that is the one method to complete this the activity critical path. So let us now this is the another method. It's like the calculating the wait duration at the nodes, and if with the old method if you calculate, you see how many paths will come and how many times we need to make the additions. Let us see. So now if you see in the old method, the previous method, so ABC is the first path. ABC, it is taking 10 hours. AFG, it is taking 8 hours. AFIJ, that is taking 15 hours. And AF and HJ, it is taking 19 hours. A, B, H, and then A, B, H, J, that is taking 18 hours. And D, E, G, it is taking 6 hours. D, E, and then I, J, it is taking 13 hours. And D, E, H, and J, it is taking 17 hours. So that means even though when you come to fourth path, that is AFHJ, you got 19 hours, but doesn't mean that unless we know all other paths and its values, we can't conclude that the 19 hours is the critical path and the maximum duration and this is the critical path. So that is why this identifying each path and its duration will take time. Instead, if you calculate the duration at the maximum duration at the node points, then we can easily calculate the critical path and then project duration. Let us take one more example so that you will understand the second method will be more easy than compare with the first method. So let us take this problem 4. Consider the following project network model used in a PERT CPM analysis. The project starts at node D and ends at node E. So node S sorry, S2 and E means end, S means it is start. Okay, instead of D, S is written. So all activities between the nodes has the same duration. The network relationships are given below. Determine the critical path for the project network. Show all the necessary steps involved in identifying the critical path. So here it is given that, so we need to, here there are some activities, they have not given the name of the activity, and they have not even given the duration of the activity, because the duration of the activity is same. Let us try to consider, don't consider 0, because 0 means the no starting and no ending. So the little a minimum we need to consider the 1, that may be days or that may be hours, we don't know, but let us say each activity will take 1 day time, 1 day time, and there are several activities. So and we need to identify what is the critical path in this network. So that is the task given here. So we need to first see so we need to first see the critical path. Let us see. So now if suppose if you want to go with the previous the first method by identifying each path and its duration, there will be a several paths, and to see every path and see the calculation, it will take a lot of time. Instead we can do one thing, we can just calculate the node at each node what is the maximum duration, then we can easily calculate the maximum duration, and we can also easily identify the critical path. Let us first start with the S. So S it is taking a 0 time, and let us go to the 1. So 1 it will take everything, we are taking 1 activity, every activity is taking same time, so we are considering as 1. So here it will be 1. Then in this the node 2 if you come, so it will be taking the 1 again, because only one arrow. Then when you come to third, it is directly going to 2 to 3, so it will be the 2, and 2 to 4 it is taking a 2 plus 1, so it will be the 3. So here if you come to this path, it is only 2, it is coming this path only 1, but maximum we are considering that is only 3. So then let us go to 3 to 6. 3 to 6 if you go, so it will be 3 plus 1, it's a 4. And if you come to this path, it will be only 2. If you come to this path, is only 1, but maximum we need to see take, so this will be 4. Then 4 to 5, so 6 to 5 we are coming, so here 4 plus 1 it will be 5. And then the 5 to and then which is, so from 6 to 7 we will go. So here the 4, from here if you come, it will be 4 plus 1, so this will be 5. If you come here, 2 plus 1, it is 3, so the maximum will be the 5, so let us write 5. Then we will go to this node 9. So if you come to this path, it is 4. If you come to this path, it will be 6, so 6. Then let us come to this the 8 node, and 5. If you come from here, it is 6, and even if you come to this path also, it will be 6 only. 5 plus the 5 plus, so it will be 6 only. So here it will be 5 plus 1, 6. And then now we will go to the next path, that is the let us go to this 11th node. So here 6 plus 1, 7, and here 5 plus 1, 6. So the 7 will be maximum here, and even if you go this way, it will be 7 only. So 6 plus 1, 7. Here maximum is 6 plus 1, 7. Here also 7. So now, sorry, if you come here, it will be 7. So if you come to this path, 7 plus 1, this will be 8. So here it will be 8. Then let us go to the next node. So next node is 13. So to go to this node 13, so 7 plus 1, 8. In this path, it will be 8 plus 1, it is 9. So which is maximum, that we will keep here. So that is 9. Then from 13th node to, let us go to 12th node, and here 9 in this path it is 6 plus 1 and the 7, and here 9 plus 1, 10. So the 10 is maximum, that we will take. And again if you go to the no, one more is there, one more 14. So if you come to 11th to 14, it will take the 9, but if you come to this path, 9 plus 1, 10. So finally you need to come to this E. So if you come to any other path, it will be less than 10, but here in this way, the 10 plus 1, it will be 11. Even in the path, in this path also, it will be 11 only. So the final will be 11. So this is how we are going to calculate the maximum duration. It will take only the 11 days. Even though the network is so big, it will take only 11 days, and there will be several paths. So if you are calculating with the second method, the first method, so it will take a lot of time, but here the 11. And what is the critical path now? So critical path, you can go with the maximum duration. So 10, 9, and then 8, and then and 7 and 6, and the maximum duration will be 5, and then 4, and from 4 then where it will go, then 3, then 2, 1, and 0. So in this way it will be going, that will be the critical path. So let us go to the next method, next problem. So this is the problem, the number 5. A project consisting of activity A to F, the immediate preceders and the duration in days are given in the table. Draw the network diagram, find critical path and project duration. So here there are activities A to F, and the activities, the description also given, that is the material procurement, framework, painting, engine, the engine manufacturing, window manufacturing, and assembly. So these are the activities, and then these are the preceders, predecessors. So this is the A, B, A, D, E. That means this activity A, it is not depending on any other activity, but activity B will start only with the after completing activity E. That is what this predecessor, the meaning. And the duration in days for activity A is 7, 12, 17, 23, 14, and 10. So these are the duration. So let us now, we need to draw the network diagram. How to draw network diagram? So first we will take the activities, and we will take the preceders, and then we will take the duration in days. Then we can able to easily draw the network diagrams. Now if you take this the three columns, and first we will start with the activity A. So activity A, the starting point will be 0, let us say node 1, and node 2 will be the ending point of activity A, and the time duration it will take 7. So this is the activity, and the activity B will be continuing the activity A, and even D also continuing the activity A. So let us try to draw this way the activity B. So this is the activity B which is continuing the activity A. So that means the 2 will become the starting point of a B, and 3 becomes the ending point of a B. So the time duration it will take 12. And next we will go to the activity C. So the activity C is continued by B. So let us draw the activity C in this way. So C, and it is taking a 17 the duration, and this is the C, and 5 is the end of this activity. And then let us go to the activity D. It is followed by, or the predecessor by D, A. So here we will draw. So then activity D and duration will be 23, and from activity E is starting continuing the activity D, and it is, let us draw this side, because F is continued by C and F, C and F, E. So that is why I am drawing the graph this way. So that means E and the 14 days, 14, and then C and E will be followed by F. So then we will be writing the F activity which is following C and E, that is F, that is a 10 duration. So that is how we are going to construct the network models. So once if you construct the network model, it will be easy to complete the it is easy to sorry, it is very easy to calculate the critical path and the project duration. So now sometimes they will be giving the information about the activities, and then we need to complete the we need to draw the network model. So this network model is drawn based on the given information. Now we need to identify the critical path. Now you already know how to identify the critical path. So you take the two paths. There are only two paths. You guys can see whichever is maximum. You can just take. So here if you take the second method, so here 0 and here 7, and here the maximum the node the weightage will be the 7 plus 12, so 19, and then here it is 7 plus 23, 30, and here it will be the 44, and finally 54. So this the path is giving the maximum the duration, so this will become the critical path. This I already explained, so I am not explaining again here. So you can easily know the critical path. Let us go to the next problem. So here this problem project consisting of following jobs whose pre-decision relationship is given below, and these are the job and these are the duration. And here the activities name they have not given, but there is a the relation between these activities and 1 to 2, that means starting point of this and ending point, the start and that is 15, and starting point and third node will be 15, second node to third node 3 days, second node to 5 nodes 5 days, third node to fourth node 8 days, third node to sixth node 12 days, fourth node to fifth node 1 day, fourth node to sixth node 14 days, fifth node to sixth node 3 days, sixth node to seventh node 14 days. So we need to draw the network diagram representing the project. Find the critical path and the total project duration. That is the problem. So let us try to solve this. First we need to take this the information which they have given, and then we need to see how much time it is taking. So first let us say the activity name we are not mentioning here, but we will only see the duration, that is 1 to 2, that is 15 days, and the 15 days 1 to 2, and then 1 to 3 again, so that is 15 days again. So 1 to 3 I will be writing here this side, and 2 to 3, so 2 to 3 I will be writing somewhere here, and that is the 3 days. So 2 to 3, sorry, 2 to 3 this way, so that is only 3, and 2 to 5, so 2 to 5 I will be writing here, and 2 to 5, and 3 to 4, 3 to 4 fourth node. So fourth node let me assume over here, so fourth node will be like this, and then 3 to 4, and 3 to 6, 3 to 6 is 12, so this is the 12, 3 to 6 sorry 3 to 6, 3 to 6, so 6 need to be here, so I am taking 5 to 6 also, 5 to 6, 5 to 6 also there, which is 3, so that is required, and then 3 to 6, 3 to 6 will be 12, and then the next will be the 4 to 5, 4 to 5 1 hour, and 1 day, sorry, 4 to then 4 to 6, 4 to 6 14 hours, sorry days, and 6 to 7, that is 14, so 6 to 7 will be this way. So that is how we will be drawing the network model. So once if you draw the network model, you know how to calculate the critical path and etc. So I will be just explaining the briefly. So first we will be calculating the node the duration, maximum duration in the node. So here the 15, and here 18, because it will be coming this way, so that is the 15, and 15 plus 3 18, and then here if you come to 5 plus this duration also there, so if you go to this way, so it will be coming around the 27, because here it will be 18 plus 8 is 26, and then we will be going here in this node, and 18 plus here in this way 26 plus 14, so here it will be 40, and then finally it will be 54. So this is the maximum duration it will be taking, and a critical path if you identify, this is the critical path, so that we need to highlight it. So this we can able to highlight it, and let us see the final the problem, that is the seventh problem. So here a PERT project network consisting of 5 activities A to E. The time estimation of these activities follow beta distribution. The predecessor's successor, P and S. Relationship between the nodes and the time estimation of the activities are given in the table. Find the critical path and variation of critical path. And activity A, B, C, D, E and P to S, and that is what they given, the predecessor and successor, 1 to 2, 2 to 3, 3 to 4, 3 to 5, 4 to 5. The optimistic time they given, the most likely time also given, and the pessimistic time also given. So what we need to find out? We need to find the critical path and variation of critical path. So here, what is this optimistic time, most likely time, and pessimistic time? That we need to first understand. Then we will understand this the problem. So the optimistic time is nothing but the it is represented by T naught, and here the estimator who is estimating the time, he will be estimating that, he will be thinking that everything goes on well and he will not come across any sort of uncertainty and estimate lower time as far as possible. He is optimistic in his thinking. So when he is starting the project, he will ideally thinking that there won't be any delay in the project, and he will be thinking that it will be starting this time and it will be ending this time, so there won't be any delay. So that is how optimistic time will be calculated. The estimator will be calculating the optimistic time. And pessimistic time, and this is represented by TP, and here the estimator thinks that everything goes wrong and expects all sort of uncertainties and estimates higher possible time. He is pessimistic in his thinking. So here the again estimator will think that if suppose what happen if tomorrow rains, what happen if some workers come, what happen if some mission fail. So like that he will be calculating and each and every the possibility and which where the project will be the delayed. So that he will be calculating, and finally he will be coming that he will be estimating the time that by considering all these things, he will be taking the calculating the time by considering all sort of uncertainty. Okay, so that is why the pessimistic time will be the more compared with the optimistic time. The next one is the likely time. So it is represented by TL. This time is in between the optimistic and pessimistic times. Here the estimator expects he may come across some sort of uncertainty, and many a time the things will go right. So he will be thinking that whatever the possibility are there to go smoothly the project, he will be thinking, and there are major uncertainties only he will be considering, so that this likely time will be between the optimistic time and pessimistic time. So here what is the time we need to take to consider one to complete one activity? So that is what we need to calculate here. So here earlier they are directly giving this is the duration it is taking to complete the activity, but here they are not giving the time duration. We need to calculate based on this optimistic time, pessimistic time and likely time. So here the expected time or average time will be TC. This is actually earlier they are giving the time duration to complete the activity, but here we need to consider this TE is equal to T naught plus 4 into TL plus TP by 6. Why we are taking 4 time of TL? Because this is the more likely time. So that is why we will take 4 weightage, 4 multiply with 4, and these two we will be adding and we will be divided by 6. So this is the average time expected time to complete the project. So by considering all these three factors we are considering, so that is why this average time we need to take, and this time we will be considering as the time duration to complete this project for one activity. And the standard deviation will be the TP minus T naught by 6. This is considered as the standard deviation, and variation is called as sigma square, and the standard deviation square, that is the variation. Let us solve one problem, previous problem by considering this. Now here this is the optimistic time, then the TL is the most likely time, and this is the pessimistic time. So these three are given, and let us calculate the TE. The TE will be 2 plus 6 plus 6. No, 2 plus 4 into 4. 4 plus 6 divided by 6, that will be 4. So like that we are going to calculate the T, and then after that sigma is nothing but Tp minus T naught by 6. 6 minus 2, that is 4, by 6, that is equal to 2 by 3. Sigma square is equal to 4 by 9. So 2 square by 3 square, 9. So then we will be getting sigma square. So in this way, for each and every activity we will be calculating the expected time and the standard deviation and variation. And now we will be first, now let us consider the activity and then the expected duration and the relation between the starting point and ending point, and then we will try to draw the network model, and then we will go to the. So now first the activity A is starting from 1 to 2, so 1 to 2, and B is starting from 2 to 3, so 2 to 3, like this we will draw. So then the activity C is starting from 3 to 4, that is the duration, is given C to D, that is D, no, correct, D is 5, and the C is starting from the 3 to 4, there is a mistake here, and then the D is starting from 4 to 5. So here I think there is a mistake in the problem, or maybe here. So but this is how it came here. Okay, so then now we can easily calculate if you consider this the model. So here the C is 8 and E is 7 and B is 6 and D is the 5. So here if you calculate what is the critical path, if you can see the critical path here 0 and 4, 10, 12 and 19. So here this path will be the critical path, so that we can able to draw here. So this is the critical path. So finally we can say the variation in the critical path will be, so the critical path is this, and 19 is the maximum duration it will take, and then the variation in critical path is equal to A plus the variation in A plus variation in C plus, this is the critical path, no? So variation in A plus variation in C plus variation in E. So the variation in A will be earlier we have seen 4 by 9 plus 1 plus 25 by 9, that will be 38 by 9. So that is how we can able to calculate the variation in critical path. So this is the variation will be 38 by 9 is the variation, that is a sigma square in the critical path. Then finally I am just concluding that. So here this video, the mastering critical path analysis through solving 7 very varied problems. This video provides a step-by-step understanding of how to identify the critical path in project networks, the vital skills in effective project planning and time management, hands-on practice with network diagrams by drafting and analyzing multiple network diagrams, and the time optimization technique using CPM. Understanding PERT variations, the video also explored the PERT based time estimation, helping learners understand how to manage uncertainty and calculate expected project duration for better decision making. So thank you.